Why is the sky dark at night? You might think the answer is obvious: the sun isn't up. But the only reason the sky looks blue during the day is that sunlight scatters off of the atmosphere. So let's rephrase the question. Why is space dark? Space is full of stars, countless stars, which are all about as bright as the sun. And in an infinite eternal universe, no matter what direction you picked, if you look far enough in that direction, you will see a star or galaxy. So the whole sky should be as bright as the sun, night and day. And since it's not, does the dark night sky suggest a limit where stars and galaxies cease to exist, marking an edge to the universe? The answer is not quite that simple. While it appears that space has no edge, but the universe itself might. Well, keep watching to find out more and to understand why space is dark. I'm going to ask you a question that you think that you know the answer to. But the real answer is far more strange and complex, and actually answers how we know that the universe is over 13.7 billion years old. Coincidentally, it also answers why we know that the Big Bang happened at all in the first place. The question is, if the universe is populated by endless stars, with each of those stars emitting an immense amount of light, then why is the night sky in all of space completely black? When we gaze at the night sky, we see two main things: stars shining brilliantly in the darkness. However, this celestial splendor might not be the same for everyone, especially if you live in a well-lit city where only a handful of stars are visible on a clear night. Nevertheless, the universe seems to hold an infinite number of stars, each radiating light. Some of these stars are incredibly bright, like our own sun, which is located 93 million miles away, but still generously illuminates our planet. The reason space appears black is rooted in two basic concepts: space and time. While the universe is incredibly vast, it's not infinitely old. It's estimated to be around 13 to 14 billion years old. Light, the fastest thing in the cosmos, moves at 300,000 kilometers per s, but even at this speed, it can't cover the entire expanse of the universe in such a short time. In simple terms, space looks black because the light from stars hasn't had enough time to reach every corner of the universe. Furthermore, the universe is expanding at a pace faster than light, which means that even with endless time, light can't fill the sky entirely because space is pulling away from it. Adding to this, the stars that emit this light aren't as ancient as the universe itself. Most stars we observe are relatively young, with ages ranging from 1 to 10 billion years. This may seem like a straightforward answer to the question of why space is black. However, things are a little more complicated than that. You might have considered the idea that space is a vacuum, containing little matter or air for light to bounce off. While this notion isn't entirely incorrect, it's not the full story. To uncover the complete answer, we'll explore two fundamental concepts: surface brightness, a key term in astrophysics, and the work of Heinrich Olbers, a German astronomer who pondered this question in 1823. At that time, the prevailing belief was that the universe stretched infinitely in all directions, and it was considered static, meaning it had no discernible motion. The idea of an expanding universe had not yet been embraced. However, Olbers noticed a fascinating fact about stars. Their surface brightness remained consistent regardless of their distance from Earth. In other words, if you could draw a direct line from a specific point on the surface of our sun, even if the sun were 10 times farther away, that point would appear dimmer in the night sky, but it would still be just as bright. So now, knowing that basic fact about surface brightness and Olbers' assumptions about the universe, here's where we get to the main issue. If the universe was infinite and static like Olbers thought, you could theoretically look in any direction in the universe, and if you looked long enough, you would very likely see a point of light. You would find a star almost no matter where you looked. Thus, we should expect to see light completely fill the night sky, making it as bright as the surface of a star, but it's not. This is Olbers' paradox. Olbers' theories on the universe weren't quite matching up with what we were actually observing about the universe. Surprisingly, during Olbers' era, the most logical scientific explanation came from an unexpected source, none other than Edgar Allan Poe, the renowned poet best known for his dark and unsettling verses. Poe, often regarded as a troubled and melancholic genius, had a lesser-known side. He was deeply passionate about science and held a firm belief that his scientific ideas would secure his legacy rather than his poetry. Following a period of personal tragedy, marked by the loss of his wife, Poe delved into the realm of physics to craft his 10th and final work, Eureka. In this unique piece, he proposed a rather unconventional idea to address the perplexing question of why the night sky remained dark. Poe's theory posited that the universe might simply not be old enough for the light from distant stars to have had the time to reach us. While Eureka was not without its scientific inaccuracies, the fundamental concepts underlying Poe's ideas demonstrated surprising accuracy. What's even more astonishing is that within the pages of Eureka, Poe put forth the notion that the universe originated from the explosive birth of a singular primordial particle. Remarkably, he inadvertently foreshadowed the Big Bang theory nearly a century before it gained widespread recognition. Despite Poe's eventual fame as a literary genius, his contributions to science were equally noteworthy. He realized his aspiration, as many now remember him not only for his poetic brilliance, but also for his prescient insights into the Big Bang theory and his progress toward resolving Olbers' paradox. My best explanation for Olbers' paradox is that we live in a dark room, so impossibly large that light has not yet had enough time to travel through it, and many of the star bulbs have already gone out. Even without using the Big Bang explanation, it can be established that the universe is finite, which would solve the Olbers' paradox problem and address the question of why the sky is not entirely bright. As we know, the amount of hydrogen in the universe is very high. However, as time goes by, this amount decreases because stars use hydrogen to create helium and heavier atoms. If the universe were infinite, the process of transforming hydrogen into heavier atoms would have been entirely completed. However, the reality is that hydrogen is a very abundant element in the universe, which leads us to think that the universe is finite, just like time. This solution could be questioned if a way were discovered to reverse the process. That is, to transform heavy atoms into simpler atoms down to hydrogen. However, this process has not been observed naturally, suggesting that the universe is a finite space-time, and therefore the stars are also finite, so they cannot illuminate space completely. But somebody did eventually solve the paradox, and it's a name that you'll likely recognize, Edwin Hubble. Yes, that Hubble. In the 1920s, Hubble discovered that entire galaxies were moving away from us, but it wasn't just the galaxies that were moving. Rather, space itself was expanding. He discovered this because he detected the wavelengths of light from galaxies and stars over time were stretching, moving further and further into infrared. This became known as a redshift. As light waves expand, the light slowly fades dimmer and dimmer until we simply can't see it anymore in the visible spectrum. Hubble also discovered that light from galaxies that were closer to us wasn't moving further away from us as fast as the galaxies that were further away from us. He made the astounding discovery that not only was space expanding, but it was expanding exponentially faster the further we look out, the further the light, the further the redshift he measured of that light. Through this discovery and measurements, we were able to determine how old the light was that we were seeing. One of the most famous examples of this is the Hubble Extreme Deep Field photo. When the universal model was changed from a static universe to an expanding universe, this solved the problem of Olbers' paradox. This meant that space was expanding faster than light could remain at a wavelength visible to us. And I'll say that again, because I don't want you to get lost on what's actually happening here. It's not that light simply hasn't reached us yet due to the universe expanding. It's that light has a finite speed, and as space expands, it stretches that light's wavelength further into infrared, diluting that light on our visible spectrum before it reaches us. That is why space is black, not because light isn't there, but because we simply can't see it. And the reason why we can't see it is because the universe itself is expanding. So while it's true that one of the reasons why space is black is that, well, Space is really big and simply not filled with enough gas for light to reflect off of. The primary reason it's not filled with light from the surface of every star in the universe is that space is expanding faster than light can travel. And of course, as you know, nothing can travel through space faster than the speed of light. But space itself is not bound by those rules. Space can do whatever it wants. Uncovering the mysteries of the universe oftentimes all starts with a very simple question. Why do apples fall from a tree? Why do planets orbit around a star? How old is the universe? And why is the night sky black? All of these questions can inadvertently lead to astounding answers. In the case of Hubble's discovery, that eventually led to the Big Bang theory being presented about a decade later. After all, it was the logical conclusion to Hubble's discoveries. If space is both expanding and accelerating, then turning the clock back meant that the universe was once much smaller, much more dense, very hot, and very, very bright. Then, 30 years later, a pair of radio astronomers in New Jersey discovered the cosmic microwave background radiation, the leftover remnants of heat signatures in the universe produced by the Big Bang. All of these discoveries and our current understanding of the earliest moments in the universe, all the way up until today, all lead back to what appears on the surface as very simple questions, questions that you may have right now. So I encourage you to ask them. I encourage you to chase the evidence and let it guide you to the answer at any cost. Because you never know if your seemingly simple question could snowball into one of the most profound discoveries the human race has ever come across. Questions like, why is the night sky and all of space completely black? Or if there exist other life forms aside from humans. And that concludes this video. If you enjoyed it, leave a like and subscribe to the channel for more content like this. But for now, goodbye, and I'll see you in the next video.